Hello friends, last two parts of the biomolecules I had given the introduction part in the part 1. In the part 2 of the biomolecules, the earth crust, what is the percentage of the elements as well as the human body along with the inorganic constituents with the formula. So now comes to biomolecules part 3, the classification. The classification of the carbohydrates along with the entire in the biomolecules also. The first of all, the biomolecules, basic biomolecules are carbohydrates, proteins, lipids and nucleic acids. These four are major biomolecules. Those are the molecules participating in our body metabolic activities. Those are very essential and important. So those are the classifications one by one. We will be discuss upcoming videos. So I will be start in this session the classification of carbohydrates. The classification of the carbohydrates. First of all, what is the meaning of the carbohydrates? The carbohydrates nothing but polyhydroxy alcohols with aldehyde or ketones and their derivatives. Polyhydroxy, many more OH groups are there, alcohol groups with the aldehyde group. Aldehyde is the functional group. The first carbon atom or second based upon the type of the sugar. The either aldehyde group acting as a functional group or else ketone. The ketone groups in some of the ketone sugars area, the ketone group CW1O acting as a functional group. So the carbohydrate definition is either polyhydroxy alcohols with the aldehyde group as a functional group or else the polyhydroxy alcohols with the ketone group as a CW1O group and their derivatives. That is the general definition of the carbohydrates. So now comes to the classification. Under this, four major groups are there based upon the number of sugars present in that. So number one is monosaccharides, number two disaccharides, number three oligosaccharides, number four polysaccharides. So number one, monosaccharides. So what is the meaning of the monosaccharides? These are the simple sugars and cannot be hydrolyzed. Here the hydrolyzed meaning is in the bond breaking time or chemical bonding time, whatever present in these monosaccharide sugars, with the help of water it will be breaking down. That is the meaning of the hydrolysis. So at that time there is no further simplifying of the sugars. That will not be happening in the monosaccharides cases. So that's why it cannot be hydrolyzed into simple sugar because this is the only simplest sugar. So monosaccharide is the primary sugar. Only one sugar is there, either with the related of aldehyde group or ketone group related single sugar is there. So even though if you are applying the water in the breakdown of the chemical bond purpose, it cannot be simplified. That's why it cannot be hydrolyzed into simple sugars. That is the monosaccharide meaning. The general formula CnH2 taken N. So this N will be indicating the number of the carbon as well as the hydrogens and oxygens because in this biomolecules area, these are the main elements present. We are talking about the carbohydrates. That's why carbon, hydrogen, oxygen having a number of elements whatever present in the monosaccharides. So here examples we have to take here. So the examples based upon the carbon atoms. How many carbon atoms present in the structure of the monosaccharides? Let us take example the third carbons. Three carbons containing either it may be aldose sugar or ketose. Just now I told here the definition. The monosaccharides may be either aldehyde group related or ketone group related. So that's why the third carbons are three carbons containing whatever the sugar monosaccharide related. If it is present aldehyde group, that means example is glyceraldehyde. And if it is ketone group is there in that three carbons containing sugar, that example is dihydroxyacetone. So same thing, the four carbons containing aldehyde related monosaccharide is erythrose. The four carbons containing keto sugar examples. The many more competitive exams, just like that Neet also there, in the either UG Neet or PG Neets also, whatever the MSc entrance related, India wide, JNU related universities conducting exams, Jawaharlal Nehru University, and whatever the major ICMR also, Indian Council of Medical Research. So whatever the competitive exams, as well as the NCRT also. So whatever the CBS related areas also, these biomolecules will be covering the biology. So like that, many more competitive exams here, they will be focusing on the examples as well as the whatever the formulas. Sometimes they will be asking, and many more times they will be asking the examples. We need to remember the examples, whether it is monosaccharides, disaccharides, oligosaccharides or polysaccharides. So now like this, next come to the 5 carbons containing sugar. In the case of aldehydes, the ribose, xylose and amino sugars. So these are the 5 carbons containing with aldehyde group. Aldehyde group means CHO group is there. In there it will be acting as a functional group. And in the case of ketosis, the 5 carbons containing example ribulose. C-double-bond group is there in the ketone areas. So next come to the 6 carbons containing example under the aldose, that is nothing but aldehyde group related, glucose, galactose, mannose. Whereas the same things, 6 carbons containing keto sugar. So fructose is the best example. The fructose, you know that this will be also competitive exam areas many more times asking which one of the sugar is sweetest. That is the fructose is the sweetest in taste. That will be also present in the honey. So whatever the honey, the bee producing that honey, so that will be having the fructose, and also whatever the human sperms, that will be also utilizing the fructose as a source to motility purpose in the case of the reproduction times. That will be, those cases will be discussed later. And now come to the 7 carbons containing carbohydrates. The example is glucoheptose, that will be under aldehyde group, and pseudoheptose, that is the keto groups. So like that, monosaccharides based upon the number of carbon atoms, either it will be aldehyde group or ketone groups. These are the examples. Now let us come to the disaccharides. So di is 2. So suppose 2 molecules of same or different monosaccharides will be forming after hydrolysis. In the bond breaking time, if you are adding water molecules, it will be split up into 2 simple sugar. Either it may be a same kind or different maybe. So it does not matter. But minimum 2 saccharides, it will be simplified. So that's why we are calling disaccharides. So best example, the formula first of all, CnH2 taken N-1. These are the N number indicating the carbon, hydrogen, oxygens. Many more repeating elements present in these carbohydrates area. That's why N number we are indicating. And X also we are using. That will be more numbers of the repeating units. Plenty of numbers, more than 3000 like that. 2000 to 3000 like that. X we are indicating. Little bit less number of the carbons, so we are using N symbol. So that is also one of the important point here. And lactose, maltose, and sucrose. These are the disaccharides, a best example under this area. And sucrose also many more times in the competitive exams asking what is the components, glucose plus fructose. These two are combining with the glycosidic bond. It will get the sucrose. It is a non-reducing sugar. And that's why which one of the following sugar is not reducing. Sugar is the best, sucrose is the best example. Many more competitive exams that question will be asking. Keep in your mind, my dear friends. And oligosaccharides, let's come to oligo. Oligo means minimum after adding of the water in the breakdown of the chemical compounds, minimum 2 to 10 monosaccharides units. Here also in the competitive exams, so how many minimum number of the monosaccharides have been releasing after hydrolysis? They will be asking that question, and that will be 2 to 10 like that. Below 10 we can consider under the oligosaccharides category. So best example here, maltodextrins. So that will be indicating. So last one is the polysaccharides. More than 10 monosaccharides we are getting after hydrolysis. So that's why you are in here plenty of molecules and repeating units. The examples further divided into here, homopolysaccharides, heteropolysaccharides. Homopolysaccharides means similar kind of the repeating units we are getting. The starch best example, glycogen, cellulose, dextrins. These are the best example under this. Similar kind of repeating units linked with the glycosidic bond. And whereas the heteropolysaccharides, mucopolysaccharides is the best example. Little bit other compounds adding in that particular area. So upcoming videos we will be discussing more about those areas. I will give the upcoming videos the chemistry part, glycosidic bond. What is that? Alpha anomers, beta anomers, whatever the epimers, dextrorotatory, rotatories, and how this will be classification, all the things of remaining proteins, lipids and nucleic acids also I will give the upcoming lectures. So here X will be more than around 2000 to 3000 like that. There is no proper number based on the type of the compound. The numbers have been slightly variation is there, but that will be bulk number. It will be indicating the C6H10O5 taken X we are indicating. So these are the brief idea about the classification of the carbohydrates. Thank you very much.